Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, today the subject of this video is this thing right here. Now, you might be saying, hey Bert, why do you have a calculator strapped to a circuit board? That looks kind of funny. And well, it does look funny, but that's not my doing. That was something that TI came up with about 1980. It's a development kit for the TMS990/189 16-bit processor. This is the same processor family that was used in things like the TI 994A. And, you know, they needed some buttons and a display for this thing. And, well, you know, we can just use the top half of a calculator for that. It's something we already produce. It'll be nice and inexpensive, and it'll work well. So that's what they did. And the result is this kind of funny looking board right here. Now, a fella named Dan sent this to me, asked me if I could get it working. He already cleaned it up a lot from when he got it, identified the chips. I'll pop a picture up here of how he packed this thing. It was an amazing packing job. Included information, everything he had found on this little USB stick right here, a folder of some information, including the parts list, which has been handy. So let's jump right in, and we'll first concentrate on getting the rest of the IC pins and stuff cleaned up so those won't cause us a problem later. And well, then we'll try connecting some power to it and see what happens. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. So what I'm going to do here is spray down the legs of the ICs that have tarnished with some deoxit. I'll take a brass pin and scrub them real gently. The brass will get most of the oxidation off, but it won't dig into the fiberglass board like a fiberglass pin would. Then I give the good a board wash with some CRC electronics cleaner and let it set. Now, one casualty of all this cleaning up is this TMS990 I/O expander chip. It's kind of like, a CIA or VIA that, Commodore used, or the 8255, from Intel, that type of thing. As you can see, it's kind of looking like a toothless old man up here. These pins just snapped off with the least bit of effort, and I've marked on the top here which ones need to be replaced. I'm going to plug this into a socket, which is on a piece of breadboard here. Slip in some pins, cut off other ICs, and solder them on. Now I took a fiberglass pin and really shined up the legs, or the stub of the legs that was left. And then I tinned those with some flux and solder. That way the legs that we cut off the donor IC would solder right on there. You might just be able to see I've done that one there as a test, and that's holding on real good, so hopefully we can save these. I reckon you can still get them, but they're not going to be that plentiful in the wild. There we go. I couldn't get a real close shot here because it's kind of delicate work, but the idea is you go 1 or 2 pins at a time. You cut off a pin from your donor IC, slip it into the socket, solder it up there, make sure it was a good joint, and then move on. It's a little time consuming, but it works. I wound up replacing 20 pins on this IC. So we've got our TM990 I/O chip in here. It's the same type of chip as what's over here. Now originally we had this power supply lead that was plugged into here. It didn't have the right connector though. Talking to the owner of this, he thought this was maybe the original cable that came with this, and I didn't want to hack it up, so I took one of these Y adapters for a PC, which are a dime a dozen, and these connectors fit over here. I wired it to the Meanwell RT50B power supply he sent. I put a AC lead on it that I had, and I'll check the voltages on here. We need ground 5 volts, -12, +12, and I put a sticker on top of the power supply that shows all those. We are missing from this board the ROM and the processor. The ROM had the same pin rot that the I/O chip did, which the main processor did. And the fellow that owns this got one of these chip carriers and soldered the ROM into that. And that's a kind of a cleaner solution than what I did. I wound up replacing 20 pins on this I/O chip here. But I think we'll go ahead and plug this ROM in and see if it works. He also included a programmer he bought specifically to read these old ROMs. This is kind of a funny old ROM. And I guess you can't use like a TL866, that type of programmer. He found one that somebody makes just for doing these, so we'll plug that in there. And this is another processor he found, which has real nice looking pins on it. Looked like it got a little scuffed up on the top though, so we'll plug these in. I'm going to check the power supply voltage. I'll plug the power supply in, and then we'll fire it up and see if we get any life out of it. Alrighty, I checked the power supply. The voltages were fine. I've got it plugged in here, and I've triple checked that all the right wires are connected to the right place. And I've got the replacement processor and the modified original ROM plugged in. So we'll try plugging this in and see what happens. Now I've got you pointed right at the LED on here, which should pops up CPU ready or something like that. Let me plug the cord into the power and we'll see what happens. And well, we've got some flashing. Just for a little bit, these LEDs at the bottom here were kind of flashing. Nothing's getting warm. Oh, got a hot VR1 there, and our 5 volts was real low. Okay, so we've got a problem on the board. Looking at the schematic, it seemed like there was only 2 chips that made use of the -5 volts that's generated by this 7905. One of them is the processor, and one is the system ROM, which is a little different sort of ROM than what we might normally be used to. And so I pulled them both out. The regulator worked fine. It didn't get hot. We had -5 volts. Put the processor in. Again, everything was just fine. And then I noticed on the ROM that's in this carrier here that a lot of the pins aren't soldered. Like, you might not be able to see that. The legs were corroded enough that it didn't solder on there real well, so that may have damaged this ROM. The code is available online, and we have a programmer. So I think, given the shape of this thing, I will get out that programmer and we'll try to program a new ROM for here and see what that changes. The master ROM on this guy is a TI TMS 4732, which is a little bit different than a normal, let's say, a 2732. It's a little different pinout. And I wasn't sure that this was exactly the same code that was on the University Basic ROM set. So I spent some quality time with the Dremel tool, and I ground down the edge of the chip where the pins were missing till I could just see the lead frame underneath. Using some flux and solder, I tinned up what was remaining of the leg stubs, as well as the parts where we cut back to expose the lead frame. We need some solder there to stick to the carrier and the bodge wires we're going to put in. I then popped the chip into that dip carrier, and I soldered in a couple of the stub pins to the legs on the chip carrier to hold everything into place. And if you look real close here, you can see that there is a little tiny wire that is soldered to the stub of the lead frame, and that goes down to the remaining legs, and that worked out really well. So as we saw, I managed to get that original ROM stuck in this dip carrier thing here. So I got out the back bit because I was chatting with the owner of this board, and he said he thought I would test the 9901, and we'll look at that in a bit. And I thought, well, we'll see if it'll read at 2532, which is, I think, the EPROM version of this. So we'll select the ROM and ripping menu, 2532. I already did this. Now, if you put an SD card in there, it'll save it without the SD card. If we press test, it's going to give us the checksum. This seems reasonable. I don't know. I didn't try to disassemble it, but it's consistent. I don't know if it's the right code. There's some code online that I think is for the University Basic option, so I don't know if the U33 ROM is the same. But we'll try it out and see what happens. Yeah, we're going to return to main menu, other series manufacturers, and TMS990, and I did manage to get this bodge back together chip out of the socket without breaking the pins. And we'll pop it in here now. We'll select that and press test. Passed all test. I've done this several times. It seems to work, so if we can get it back in the socket without breaking the soldered on pins, perhaps it'll work. So we'll give it a shot. Okay, got the chips plugged back in where they go, and I'm going to be kind of stretching one arm across the board here. I'm going to measure the 5 volts on the power supply when I plug it in, and we'll see if this thing does anything this time. Well, we got some LEDs. We've got 5 volts, minus 12, 12, and the output on our regulator is minus 5.1. So we've made some type of progress, maybe. Well, it appears to be getting hot this time. Now, I don't know if we need all 4 of these 2114s in here. That may be. So I don't know if that switch does anything. So I'll investigate if we need all 4 2114s in there, and if so, I think he might have included some, and we'll try that. Okie doke. I looked back at the video on YouTube where a guy is repairing one of these and then upgrading it to the University Basic to see what he started out with, and there was one of these 2114 RAMs in both of these sockets. So fortunately, the owner of this, Dan, had sent some extra 2114s, and I plugged one in here. And then I tried firing it up, And I did a dance. Sorry, you missed the dance. I know everybody would look forward to that. Not. I'm going to reach back here and plug it in. You saw this little Cylon scan here and the beepity beepity beep. And you can't see it from your angle, but it says CPU ready. We'll do a little shaky cam. CPU ready. All the digits are there. It just doesn't come across with all this glare in here. There we go. CPU ready. And you can see it's flashing the deal there. Okay, I'm going to have to come up with some way to get rid of this glare so we can see the screen there. What happens if we toggle this load button? That just resets it. Okay. What happens if we press M? 200. That didn't do anything. Okay, I'm going to have to read the directions, figure out how to use this thing so we can poke in a Hello World type program and see what else might be wrong with it, or see if it's working all okay. The display seemed awfully dim, so I thought I might polish that red plastic there. I covered up where Texas Instruments is painted on it with a piece of Cap-Tan tape, and then polished it a few times with the coarse Novus number 3, 2 or 3 times with the fine number 2, and then cleaned it off real good with the number 1 kind of polish and protector. And that did a really good job. It really improved the view of the display. So I've got it running again. You can see how much better that display looks with that polished. What we're going to do here is enter a program. This is a program that was in the manual. I'll pop it up here on the screen. So I'm going to follow along here with the printout. So if we hit return, we get a question mark. We press M for memory, type in 200 and return, and that shows us what's at memory location 200, which is not what we want in there. So we type what we want in there. We want 02E0, then we press space, and we want 0300 space 0200 space. I skipped a line. Now we're down at 0208 0201 space 000 F space A001 space 2E80 space 2F41 space. I'm going to go ahead and hit return again and go back into memory 200. And we're going to check our work. So we got 2E0, 0300, 0200. This is the one I skipped. 0021, 0201, 000F, A001, 2E80, 2F41. Okay, and we're back at the question mark prompt. And to run this, we're going to enter P to change the program counter. We're going to change the program counter to 0200. I guess I should have mentioned before what this program does. It adds two numbers and displays the result in the display here. 0200. Return. Get the question mark and we press E for execute return, and we get 0030 as the display. Let's see if I can zoom in a little more directly on that display for you. Yeah, that looks real nice. And you have to just about be on top of it to see it right. I thought it might be a little more at an angle being from a calculator, but it's just about a straight down view. But it looks real good. Well, we've got this thing working now. We're able to enter a program and have it execute and do the right thing. Now the owner of this, I've been talking to him, and we found the mating connectors for the power input here and the cassette interface, and he's ordered those. He's also ordered the EPROMs that we need for these two ROM locations. We already talked about this one being the main system ROM for the use like this is a TMS 4732 that can be replaced with a TMS 2532 or another manufacturer 2532 EPROM. This one here is a TMS 2716, which is a different pinout entirely to a regular like 2716 or 27C16 EPROM. So that's unique to this. It takes -5 volts in addition to 5 volts. But he found some of those. We've got a way to program that guy. I think I can program these at work. I have to look into that, but we'll try to get that done. And at least this works good enough right now. I was able to read the file off of it with the back bit. So we'll leave it there. We'll get in the connectors. We'll get in the ROMs so we can burn some ROMs. We still need to check the serial port over here. It said something in the manual about being able to use the serial port with this configuration rather than typing on the keypad here. So we'll give that a try. We'll burn some new EPROMs and see if we can get the basic working a little bit, make some new cables, things like that, see if the cassette interface works. If he wants to get the remote control for the cassette working, it needs a little relay right here. I'll have to look up what part number that is. And I thought I might swipe the connectors off this Sharp CE150 board for the cassette. Just make a cable and a little board with those on there. And that way, if he wants to pop this in a box or something, he can mount those along with the power supply in the box, and it'll look real nice, and it'll still be easy to use. So it'll probably take a couple weeks to get all that stuff in, so we'll get back on this then. In the meantime, if you have any questions or comments, leave them in the comment section down below. I would love to hear from you. Thanks to everyone who helped support the Hey Birt channel. It is greatly appreciated. And until next time, bye.